Hello, in this lecture we will find the radius of a circle. You can see in the drawing a circle. The center of this circle is at point O. Chord AD equals to 10 units and chord BC in the circle equals to 5 units, and this angle is a right angle. It equals to 90 degrees, and we want to find out the radius of this circle. First of all, I will explain you what is a peripheral angle. Okay, a peripheral angle is an angle inside the circle its vertex is on the circle and its curves are chords in the circle. So I will read again the definition of a peripheral angle. A peripheral angle is an angle inside the circle. Its vertex is on the circle and its curves are chords in the circle. I will give you an example of a peripheral angle in order to clarify the issue. Actually, angle alpha is a peripheral angle because it is inside this circle. The vertex of angle alpha is at point A, and point A is a point on the circle itself, and the curve AB of angle alpha is chord in this circle, and curve AC of angle alpha is also chord in this circle. And actually angle alpha rests on chord BC in the circle. Okay, again, angle alpha is defined as a peripheral angle because it is angle inside this circle. The vertex of angle alpha is at point A, and point A is point on the circle, and the curve AB of angle alpha is chord in this circle, and also curve AC of angle alpha is chord in this circle, and actually angle alpha rests on chord BC in this circle. For that reason, angle alpha is a peripheral angle. Okay, so a peripheral angle is an angle inside the circle. Its vertex is on the circle, and its curves are chords in the circle. Okay, that is the definition of a peripheral angle. Okay, in the next step we will connect together. Actually, we will draw a chord through points A and O. You should remember that point O is the center of this circle. So I will draw a chord for points A and O. The touching point between the circle and the chord will be defined as point P, as point M. The touching point between the chord and the circle will be defined as point M. Okay, again, the touching point between the circle and the chord is defined as point M, and actually chord AM is the diameter of this circle. Again, chord AM is the diameter of this circle. I will write it down. Code AM in the red color is the diameter of the circle because chord AM passes through point O, that is the center of this circle. Because because chord AM passes through the center of the circle, that is to say, chord AM passes through point O. For that reason, chord AM is the diameter of this circle. So I will read again the things that I wrote. Chord AM is the diameter of the circle because chord AM passes through the center of this circle, that is to say, point O. Point O is the diameter of this circle, and chord AM passes through point O. For that reason, chord AM is the diameter of this circle. Any chord that passes through the center of the circle is defined as the diameter of the circle, and for that reason, AM that passes through the center of this circle is defined as the diameter of this circle. In the next step, we'll connect together points D and M by a straight line. We connected together points M and D by a straight line. Actually, we have rule number one, that states that peripheral angle that rests on the diameter of a circle equals to 90 degrees. So I will read again rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. I will give you an example in order to clarify the definition of a peripheral angle that rests on the diameter of a circle. In this circle, if the center of this circle is chord, if the diameter of this circle is chord AB, okay, chord AB is the diameter of this circle. So according to rule number 1, any peripheral angle that rests on chord AB, that is the diameter of this circle, will be equal to 90 degrees. So, for example, if we have a peripheral angle ACB, angle ACB is a peripheral angle and it rests on chord AB, that is the diameter of this circle. So according to rule number 1, peripheral angle ACB equals to 90 degrees. Okay, according to rule number 1, angle ACB equals to 90 degrees because of the fact that it rests on the diameter of this circle, that is to say, it rests on chord AB, that is the diameter of this circle, and for that reason, according to rule number 1, it equals to 90 degrees. Okay, I will write it down. So peripheral angle ACB rests on chord AB, and chord AB is the diameter of the circle. For that reason, according to rule number 1, it equals to 90 degrees. So we can deduce from it, according to rule number 1, that peripheral angle ACB equals to 90 degrees. Okay, any peripheral angle that rests on the diameter of a circle equals to 90 degrees. If we will draw another peripheral angle, that rests on the diameter of the circle, according to rule number 1, it also will be equal to 90 degrees. So actually peripheral angle ADB also rests on AB, that is the diameter of this circle. For that reason, according to rule number 1, it equals to 90 degrees. Okay, according to rule number 1, peripheral angle ADB that rests on the diameter of this circle equals to 90 degrees. Okay, we actually can implement this rule in our circle. Because in our circle we have the peripheral angle ADM, so peripheral angle ADM rests on chord AM, and chord AM is the diameter of this circle. So according to rule number 1, peripheral angle ADM equals to 90 degrees. So peripheral angle ADM equals to 90 degrees. I will read again the things that I wrote. Peripheral angle ADM rests on chord AM, as you can see from the drawing. Peripheral angle ADM rests on chord AM, and chord AM is the diameter of this circle. So according to rule number 1, peripheral angle ADM equals to 90 degrees. Okay? In the next step, we will focus on the right triangle ADM. Triangle ADM is a right triangle because of the fact that angle ADM equals to 90 degrees. For that reason, triangle ADM is a right triangle. So we'll focus on the right triangle ADM. We'll define angle AMD as alpha. and angle AMD will be defined as beta. I write it down. Angle AMD equals to alpha, while angle MAD equals to beta. Again, in the right triangle AMD, angle AMD equals to alpha, angle AMD equals to alpha. We defined angle AMD that it is equals to alpha, and angle MAD angle MAD equals to beta. Angle MAD equals to beta according to our definition. We know that the sum of the angles in a right triangle equals to 180 degrees. So the sum of the angles in any triangle in the world equals to 180 degrees. And especially it is true in the right triangle MAD. The sum of its angles equals to 180 degrees. So that is to say alpha plus beta plus 90 degrees equals to 180 degrees. So we actually will create the equation number 1 that states that the sum of the angles in the right triangle ADM equals to 180 degrees. That is to say alpha plus beta plus 90 degrees equals to 180 degrees. Okay, so our first equation states that the sum of the angles in the right triangle AMD equals to 180 degrees. That is to say alpha plus beta plus 90 degrees, that is the sum of the angles in the right triangle AMD, equals to 180 degrees. Okay, the sum of the angles of the right triangle AMD is alpha plus beta plus 90 degrees, and it equals to 180 degrees. It is true for any triangle in the world. The sum of the angles of any triangle in the world equals to 180 degrees. Now we will subtract from equation number 1 90 degrees. So we subtracted from equation number 1 90 degrees. Alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 180 degrees minus 90 degrees equals to 90 degrees. In the next step, we will subtract alpha from equation number 1, from this equation. So we subtracted alpha from equation number 1. We got that alpha plus beta minus alpha equals to beta, and 90 degrees minus alpha equals to 90 degrees minus alpha. So we got equation number 1 that states that beta equals to 90 degrees minus alpha. Okay. In the next step, we will connect together points A and B by a straight line. We connected together points A and B by a straight line. We will call to the vertex of this right angle L. Okay, the vertex of this right angle, the vertex of this angle that equals to 90 degrees is defined as L. So we have here a right triangle ABL. And actually, we have rule number 2 that states two peripheral angles, or two peripheral angles that rests on the same chord equal to each other, or peripheral angles, peripheral angles that rests on the same chord are equal to each other. I will read again Rule number two states that peripheral angles that rest on the same chord are equal to each other. In order to clarify rule number 2, I will give you an example. If we have two peripheral angles that rest on the same chord, for example, we have peripheral angle alpha as you can see from the drawing, peripheral angle alpha rests on chord BC. Again, peripheral angle alpha rests on chord BC. But we have another peripheral angle, beta, that rests on the same chord BC. As you can see from the drawing, peripheral angle beta rests on the same chord BC. So actually we have two peripheral angles, angle alpha and angle beta, that rests on the same chord BC. According to rule number 2, they are equal to each other. That is to say, alpha equals to beta. Okay, so I write it down. Peripheral angle alpha and peripheral angle beta rest on the same chord that is to say, they rest on the same chord BC. For that reason, according to rule number 2, they are equal to each other. that is to say alpha equals to beta. Okay, I will read what I wrote again. Alpha and beta, that are peripheral angles, rest on the same chord BC. Alpha rests on chord BC and also beta rests on the same chord BC. So according to rule number 2, because of the fact that they rest on the same chord, they are equal to each other. That is to say, alpha equals to beta because of the fact that they rest on the same chord BC. Okay, so actually we can implement rule number 2 in our circle. Because in our circle we have angle AMD that equals to alpha, or peripheral angle AMD equals to alpha, and peripheral angle AMD that equals to alpha rests on chord AD. Okay, I read what I wrote. Peripheral angle AMD that equals to alpha it rests on chord AD. Okay, peripheral angle AMD that equals to alpha rests on chord AD. And we have peripheral angle ABD, again peripheral angle ABD also rests on chord AD. Okay, peripheral angle ABD also rests on chord AD. Okay, peripheral angle ABD also rests on chord AD. Peripheral angle ABD also rests on chord AD as angle alpha that rests on chord AD. So according to rule number 2, that peripheral angles that rest on the same chord are equal to each other, So those two angles, angle alpha and angle ABD, equal to each other. According to rule number 2, they are equal to each other. That is to say, angle ABD equals to angle alpha. So I will read again what I wrote. So actually, because of the fact that those two angles, angle ABD and angle alpha, rests on the same chord AD, according to rule number 2, they are equal to each other. Angle ABD equals to alpha. Okay? Again, because of the fact that those two angles, angle ABD, rest on chord AD and also angle alpha rests on the same chord AD, according to rule number 2, they are equal to each other. That is to say, angle ABD equals to alpha. Okay? We have two angles, angle ABD and angle alpha, that both of them rest on the same chord AD. So according to rule number 2, they are equal to each other. That is to say, angle ABD equals to angle alpha. That's all. Okay? So according to rule number 2, angle ABD equals to alpha. Okay? Angle ABD equals to alpha. Okay, angle ABD equals to alpha because of the fact that both those two angles, angle ABD and angle alpha, rests on the same chord AD, so they are equal to each other. That is to say, angle ABD also equals to alpha. In the next step, we will focus on the right triangle ABL. And we'll define angle BAL as x. Okay, angle BAL will be defined as x. This angle will be defined as x. Okay, we'll write it down. Angle BAL equals to x according to our definition. Okay, in the right triangle ABL, angle BAL is defined as x. Okay, in the right triangle ABL, angle BAL is defined as x. We know the sum of the angles, that the sum of the angles in any triangle equals to 180 degrees, and especially it is true in the right triangle ABL. The sum of its angles equals to 180 degrees. That is to say, alpha plus x plus 90 degrees equals to 180 degrees. So I will create the second equation that states that the sum of the angle in the right triangle ABL equals to 180 degrees. Okay, so our second equation will be the sum of the angles in the right triangle ABL, that is to say alpha plus x plus 90 degrees, equals to 180 degrees. So the second equation states that the sum of the angles in the right triangle ABL equals to 180 degrees. That is to say, the sum of the angles in the right triangle ABL is actually alpha plus x plus 90 degrees. Alpha plus x plus 90 degrees, and it equals to 180 degrees. Now we will subtract 90 degrees from equation number 2. So we subtracted 90 degrees from equation number 2. Alpha plus x plus 90 degrees minus 90 degrees equals to alpha plus x, and 180 degrees minus 90 degrees equals to 90 degrees. In the next step, we subtract alpha from equation number 2. So we subtracted alpha from equation number 2. Alpha plus x minus alpha equals to x. 90 degrees minus alpha equals to 90 degrees minus alpha. So equation number 2 states that x equals to 90 degrees minus alpha. Okay. But we know from equation number 1, equation number 1 states that beta also equals to 90 degrees minus alpha. So I write it down. according to equation number 1, beta also equals to 90 degrees minus alpha. Okay, according to equation number 1, beta also equals to 90 degrees minus alpha. So we have equation number 2 that states that x equals to 90 degrees minus alpha, and equation number 1 states that beta equals to 90 degrees minus alpha. Actually, we can integrate those two equations together. We have equation number 2 that states that x equals to 90 degrees minus alpha. Okay, according to equation number 2, x equals to 90 degrees minus alpha. And according to equation number 1, 90 degrees minus alpha equals to beta. Okay, so we can add here that 90 degrees minus alpha equals to beta according to equation number 1. 90 degrees minus alpha equals to beta according to equation number 1. Okay, 90 degrees minus alpha equals to beta according to equation number 1. And according to equation number 2, x equals to 90 degrees minus alpha. Okay, so we have this equality, and from this equality we can see that x equals to beta. We can deduce from this equality that x equals to beta. Okay, x equals to beta, so actually angle BAL equals to x, and we know that x equals to beta, so instead of x we can write beta because x equals to beta. Okay, x equals to beta, so instead of x we wrote beta. And we have angle BAL that equals to beta, and angle MAD also equals to beta. Actually, we have rule number 3. Actually, rule number 3 states that equal peripheral angles rest on equal chords or equal arcs. Again, equal peripheral angles rest on equal chords or equal arcs. Okay, so I will write it down. Rule number 3 states that equal peripheral angles rest on equal chords or equal arcs. Okay. So I will read rule number 3 again. Rule number 3 states that equal peripheral angles rest on equal chords or equal arcs. So I will show you an example of rule number 3 in order to clarify it. Actually, if we have equal peripheral angles, let's say that this angle equals to alpha, and actually angle alpha rests on chord BC. So you can see from the drawing, peripheral angle alpha rests on chord BC, and we have another peripheral angle beta So actually peripheral angle beta rests on chord EF and peripheral angle alpha rests on chord BC. Actually both of them equal to alpha, we have equal peripheral angles, that is to say both of those angles equal to alpha. For that reason they are equal to each other. So equal peripheral angles rest on equal chords. The blue angle alpha rests on chord BC, and the red angle alpha rests on chord EF. So according to rule number 3, because of the fact that those two angles are equal to each other, they also rest on equal chords. That is to say BC equals to EF. Okay, so I will write it down. So uh, because of the fact that those two peripheral angles are equal to each other, are equal to each other, both of them equal to alpha, both of them equal to alpha. So according to rule number 3, they rest on equal chords. That is to say, so the blue angle alpha rests on chord BC and the red angle alpha rests on chord EF. And according to rule number 3, they rest on equal chords. So BC equals to EF. So I will explain again. Because of the fact that those two peripheral angles are equal to each other, they also rest on equal chords. The blue angle alpha rests on chord BC and the red angle alpha rests on chord EF. And according to rule number 3, they rest on equal chords. So BC equals to EF. Okay? Again, equal peripheral angles. Those two two peripheral angles are equal to each other, both of them equal to alpha. So equal peripheral angles rest on equal chords. So this angle alpha rests on chord BC and this angle alpha rests on chord EF. So BC equals to EF because of the fact that equal peripheral angles rest on equal chords. This angle is alpha, this angle is alpha. For that reason, they rest on equal chords. That is to say, BC equals to EF. Okay, so we can implement this rule in our circle. We have angle BAC that equals to beta. Angle BAC equals to beta. And it rests on chord BC. While angle MAD also equals to beta, and it rests on chord MD. While angle MAD equals to beta, also to beta, and this angle beta rests on chord MD. And according to rule number 3, it states that equal peripheral angles rest on equal chords, MD will be equal to BC. So I'll read again what I wrote. Angle BAC equals to beta and it rests on chord BC. Angle BAC equals to beta and it rests on chord BC. While angle MAD that also equals to beta and it rests on chord MD. While angle MAD that also equals to beta, it rests on chord MD. Okay, so angle BAC rests on chord BC and angle MAD rests on chord MD. So according to rule number 3, equal angles, angle BAC equals to angle MAD, both of them equals to beta. According to rule number 3, it states that equal peripheral angles rest on equal chords. MD equals to BC because this is angle beta and it rests on chord BC, and this is also angle beta and it rests on chord MD. For that reason, according to rule number 3, they rest on equal chords. So MD equals to BC or BC equals to MD because equal peripheral angles rest on equal chords. Those two angles are equal to each other, so they rest on equal chords. So chord BC equals to chord MD. Again, those two angles are equal to each other. They both equal to beta, so they rest on equal chords. This angle rests on BC and this angle rests on MD. So BC equals to MD because of the fact that they rest on equal chords. For that reason, BC equals to MD, or MD equals to BC. Okay, so according to rule number 3, equal peripheral angles rest on equal chords, so MD equals to BC. Okay. So actually, our conclusion is that MD equals to BC according to rule number 3, but it is given us in the question that BC equals to 5 units. Okay, as you can see here, BC equals to 5 units. So we can add that here that BC equals to 5 units according to what is given us in the question. Okay, BC equals to 5 units. So we can deduce from this equality that MD equals to 5 units. Okay, I will write it again. So we have the equality that states that MD equals to BC equals to 5 units. So we can deduce from this equality that MD equals to 5 units. Okay? We can deduce from it that MD equals to 5 units. Okay, so we can write here that MD equals to 5 units. So in the next step, I will draw right triangle AMD again. So this is the right triangle AMD. Side AD equals to 10 units, side MD equals to 5 units, and AM is the diameter of this circle, so I will mark it as D, abbreviation for diameter. AM is also the hypotenuse of this right triangle, and we will use the Pythagorean theorem in order to find out the value of D. Okay? So the Pythagorean theorem apply only on right triangles, and the Pythagorean theorem states that in a right triangle, because it applies only on right triangles, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will read the Pythagorean theorem again. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. We will implement the Pythagorean theorem in our right triangle. So according to the Pythagorean theorem, the square of the hypotenuse, that is to say AM squared, that will be our third equation, AM squared equals to the sum of the squares of the perpendiculars, equals to AD squared plus MD squared. So AM squared, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to AD squared plus MD squared. But we know that AM equals to D, AM equals to D, AD equals to 10 units, and MD equals to 5 units. Okay, it is the, we know that MA equals to D, MD equals to 10 units, and MD equals to 5 units, so we can substitute AM by D, we can substitute AD by 10, and we can substitute MD by 5. So we'll do it now. So we got that this square equals to 10 square plus 5 square. 10 square is 100, 5 square is 25, 100 plus 25 equals to 125, so I write it down. So we got that this square equals to 125. Now we will take a root out of equation number 3. We get that d equals to the root of 125. We know that 125 equals to 25 times 5. So I write it down. Okay, 125 equals to 25 times 5. So we got that d equals to the root of 25 times 5. Actually, we can separate the root to two roots according to the rule that the square root of a times b equals to root a times root b. You can write that c equals to root 25 times root 5. So according to the rule that the root of a times b equals to root a times root b, we can separate this root to two roots. So d will be equal to root 25 times root 5 according to this rule. So the root of 25 equals to 5, so I write it down. Here the root of 25 equals to 5, so we got that d equals to the root of 25, that is 5, times root 5. But we know that the diameter of any circle equals to 2 times the radius. So we create the fourth equation that states that the diameter of any circle equals to 2 times the radius. And actually d is the diameter of the circle because it equals to AM, and AM is the diameter of the circle. So you can see AM is the diameter of the circle and d equals to AM. So actually it is true for any circle, the diameter of any circle equals to 2 times the radius, and especially it is true in our circle. We know that d equals to 5 times root 5, so we can substitute d by 5 times root 5 because d equals to 5 times root 5. Okay, we substituted d by 5 times root 5 because d equals to 5 times root 5, and we got that 5 times root 5 equals to 2 times the radius. Now we can divide the equation number 4 by 2, and we'll get the radius of this circle. So we divided equation number 4 by 2, we got that the radius of this circle equals to 5 times root 5 over 2. Or we can also write it in terms of numbers. Of the radius of the circle equals to 5 times root 5 over 2 units. Or in terms of numbers, we can write that the radius of the circle equals to 5.59 units. Okay, the radius of the circle equals to 5.59 units. Okay, so the radius of this circle equals to 5.59 units, so it also can be written in another way. The radius of this circle equals to 5 times root 5 over 2 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. We know that the center of this circle is at point O. Chord AD equals to 10 units and chord BC equals to 5 units. And this angle is a right angle, or angle ALB is equals to 90 degrees. And we want to find out the radius of this circle. The definition of a peripheral angle is a peripheral angle is an angle inside the circle. Its vertex is on the circle and its curves are chords in the circle. Okay, so I gave you an example of a peripheral angle. Alpha is a peripheral angle because of the fact that alpha is inside the circle, and the vertex of angle alpha is at point A, and point A is a point on the circle itself, and side AB, or curve AB of angle alpha is chord in this circle, and also curve AC of angle alpha is also chord in this circle, and actually angle alpha rests on chord BC. So for that reason, angle alpha is a peripheral angle. Okay, and in the next step, I drew a chord through points A and O, and we call to the touching point between the circle and the chord point M, and actually chord AM is the diameter of the circle, because chord AM passes through the center of the circle, that is to say, chord AM passes through point O, that is the center of this circle. For that reason, it is the diameter of this circle, because any chord that passes through the center of a circle is defined as the diameter of that circle. Okay, so chord AM is the diameter of this circle, and we have actually rule number 1. Before that, we connected together points M and D by a straight line, and we have rule number 1 that states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So actually, if we have a peripheral angle, ACB is a peripheral angle, and AB is the diameter of this circle, and ACB rests on chord AB, that is the diameter of this circle. So according to rule number 1, it equals to 90 degrees. The same thing is true for peripheral angle BDA. Peripheral angle BDA rests on AB, that is the diameter of this circle. For that reason, peripheral angle BDA equals to 90 degrees. Okay, so we implemented this rule in our circle, because in our circle we have angle ADM that rests on chord AM, and chord AM is the diameter of this circle. So according to rule number 1, peripheral angle ADM equals to 90 degrees. Okay, and actually we defined angle DMA as alpha and angle MAD as beta, and we know that the sum of the angles in any triangle equals to 180 degrees, and especially it is true in the right triangle MAD, the sum of its angles is 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. This is our first equation that states that the sum of the angles in the right triangle ADM equals to 180 degrees. Alpha plus beta plus 90 degrees equals to 180 degrees. From equation number 1, we got that beta equals to 90 degrees minus alpha. Okay? And we have rule number 2 that states that peripheral angles that rest on the same chord are equal to each other. So actually, if we have two peripheral angles, peripheral angle alpha and peripheral angle beta, that rest on the same chord BC, peripheral angle alpha rests on chord BC and peripheral angle beta also rests on the same chord BC. So according to rule number 2, if we have two peripheral angles that rest on the same chord, like this example, they are equal to each other. That is to say, alpha equals to beta, according to rule number 2. Okay, so we actually can implement rule number 2 in our circle. Because we have angle AMD that equals to alpha and it rests on chord AD. And we have also angle ABD that also rests on the same chord AD. So according to rule number 2, angle alpha equals to angle ABD, or ABD equals to angle alpha, because both of them, those two angles, peripheral angles, rest on the same chord AD. So therefore, according to rule number 2, they are equal to each other. That is to say, angle ABD equals to angle alpha. Okay, so I marked angle ABD as alpha, and in the right triangle ABL, we define the angle BAL as x, and we know that the sum of the angles in any triangle equals to 180 degrees, and it is true especially for the right triangle ABL. The sum of its angles equals to 180 degrees, so actually alpha plus x plus 90 degrees equals to 180 degrees, and this is actually our second equation that states that the sum of the angles in the right triangle ABL equals to 180 degrees. That is to say, alpha plus x plus 90 degrees equals to 180 degrees. Okay, from the second equation we got that x equals to 90 degrees minus alpha, but we know from the first equation that beta also equals to 90 degrees minus alpha. So we can integrate equation number 1 and 2 together. According to equation number 2, x equals to 90 degrees minus alpha, and according to equation number 1, 90 degrees minus alpha equals to beta. So we can write here that 90 degrees minus alpha equals to beta according to equation number 1, and according to equation number 2, x equals to 90 degrees minus alpha. So from this equality, we can deduce that x equals to beta. Okay, x equals to beta. So we substituted x, angle BAL equals to beta, because we defined from the beginning that angle BAL equals to x, and now that we know that x equals to beta, we can substitute x by beta. So we substituted x by beta, and we know that angle BAL equals to beta, and we also know that angle MAD also equals to beta. And we have rule number 3 that states that equal peripheral angles rest on equal chords. So actually, if we have two equal peripheral angles, alpha and alpha, according to rule number 3, they rest on equal chords. Because of the fact that they equal to each other, they also rest on equal chords. That is to say, BC equals to EF, because equal peripheral angles rest on equal chords. Alpha equals to alpha, For that reason, BC equals to EF. Okay, so that is the rule number 3. We can implement rule number 3 in our circle because we have angle BAC that equals to beta and it rests on chord BC, and we have angle MAD that also equals to beta and it rests on chord MD. According to rule number 3, equal peripheral angles rest on equal chords. This angle is beta and this angle is also beta. Okay, so they rest on equal chords. So MD equals to BC. Because of the fact that those two angles are equal to each other, they also rest on equal chords. That is to say, MD equals to BC because they rest on equal chords. Angle MAD rests on chord MD and angle BAC rests on chord BC. And according to rule number 3, they rest on equal chords. So MD equals to BC. Okay? MD equals to BC according to rule number 3. So we know that MD equals to BC, but it is given us in the question that BC equals to 5 units. According to rule number 3, MD equals to BC, and according to what is given us in the question, BC equals to 5 units. So we have this equality, and from this equality we can deduce that MD also equals to 5 units. Okay? And so we can write here that MD equals to 5 units. We draw the right triangle AMD again. We have side AD of the right triangle AMD that equals to 10 units, side MD equals to 5 units, and AM, this is the diameter of this circle. We know that AM is the radius equals to the radius of this circle, so we wrote that AM, we called it D, abbreviation for diameter, and we used the Pythagorean theorem in order to find out the value of D. According to the Pythagorean theorem, that it applies only to right triangles. In a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse, AM square, equals to the sum of the squares of the perpendiculars, equals to AD square plus MD square. Okay, so this is our third equation. AM square equals to AD square plus MD square. But we know that AD equals to 10 units, MD equals to 5 units, and AM equals to D. It is the diameter of the circle. So we can put the data inside the equation number 3, and we found out that D equals to 5 times root 5 units, but we know that D is the diameter of the circle, and in every circle the diameter of the circle equals to 2 times the radius, so this is our fourth equation. And the third equation states that the D equals to 5 times root 5 units. So we can substitute D by 5 times root 5 because d equals to 5 times root 5. We substituted d by 5 times root 5, and we got that 5 times root 5 equals to 2 times the radius of the circle. We divided equation number 4 by 2, and we got that the radius of this circle equals to 5 times root 5 over 2 units, or in numbers, the radius of this circle equals to 5.59 units. Okay, the radius of this circle equals to 5.59 units, or it can also present it that the radius of this circle equals to 5 times root 5 over 2 units. Okay, thank you very much.